Have you ever really stopped to think about what consciousness is? Not as some big philosophical mystery, but what if it's more like a piece of engineering? Today, we're going to dive into a really fascinating theory that looks at consciousness not as magic, but as the ultimate software running on our biological hardware. So, instead of getting bogged down in the why, this theory flips the script and asks a different question. What if consciousness isn't some unsolvable riddle? What if it's a mechanism? A biological system that, yeah, it's incredibly complex, but it's something we can actually start to understand. And the key to unlocking this whole thing is to borrow an idea from a world we all get: computers. This model suggests that the brain's activity isn't just some chaotic electrical storm. No, it's an organized system, and we can think about it as having three distinct but totally interconnected layers. So first, we've got the hardware. That's the physical brain itself. Running on top of that, you have the middleware, all the raw biological processes. And then finally, we get to the software. This is the world of abstract thought, of meaning. So let's break down what each of these layers really is. Okay, let's start with the hardware. This is the physical stuff, right? The wetware. We're talking about the billions of neurons, the intricate web of blood vessels. It's the actual biological machine that all of our thoughts are running on. Next up, we have the middleware. Now, you can almost think of this as the brain's operating system. It's that constant hum of electrical and chemical activity that's happening on the hardware. It's the raw, dynamic process that really brings the physical brain to life. And finally, we get to the software. Now this is where the really cool abstract stuff starts to happen. At this level, specific patterns of neurons firing are actually given meaning. So a certain cluster of signals, it isn't just electricity anymore, it's interpreted as an instruction, something like bend your thumb. So if you look at the simplest biological systems, it's basically a direct circuit. A stimulus comes in, like say you touch a hot flame, and a response immediately goes out. You pull your hand away. It's a pure one-to-one reaction. Simple as that. But here's where evolution gets really clever. What happens when a new component gets inserted into that simple circuit? A bundle of neurons that doesn't connect directly to the stimulus or the response, but just sits right there in the middle. This changes the entire game. That middle group of neurons isn't just passing the signal along. It becomes an observer, a manager. It takes in the stimulus, and then it decides on the response. That simple circuit now has a middleman. Now, this new middleman is what the theory calls an observer object. And if you've done any coding, that word object should sound familiar. It's like a self-contained unit with a specific job. And its fundamental job here is to make a really simple distinction. Is that first group of neurons firing, or is it not? It's the brain asking its first yes or no question about its own activity. And the real beauty of this whole system is that it can scale. You can have an observer that watches the stimulus, but then you can add another observer that watches the first observer. You can just keep building layers upon layers of management, creating this incredible complexity. Okay, so we've gone from a simple reflex to this really complex layered system of observation. But how in the world does this get us to the actual feeling of awareness, the thing we call consciousness? Right, here's the key idea. Consciousness isn't just making a distinction. It's the moment the brain's software creates a brand new object whose only job is to recognize that a distinction has just been made. The brain is literally becoming aware of its own processes. Think about it like this. Your basic software can see a lion and trigger the flee response. But a conscious software has another layer on top of that says, hey, I am currently running the See a Lion program, and that is the dawn of awareness. This also gives us a really clear way to separate consciousness from self-consciousness. Self-consciousness pops up when the software creates an object to represent its own host, the physical body. So the thought is no longer just, there is a threat, it becomes, that threat is a danger to me. So this all leads to a pretty obvious question, right? If our brains are just these super fancy biological computers, why haven't we built a conscious AI yet? Well, the theory suggests the answer lies in the fundamental nature of our hardware. And here's the fundamental difference. A digital computer, it works with discrete bits. It's either on or off, a 0 or a 1. Our brain, though, it's a machine of the continuum. It's operating on this vast, messy, incredibly powerful spectrum of chemistry and electrical gradients. That's a level of complexity we just can't replicate yet. I mean, we always hear that number 100 billion neurons, and it's so huge it's hard to even wrap your head around. But honestly, even that staggering number doesn't capture the whole picture. It doesn't even begin to account for all the other chemical and mechanical processes that add to the brain's incredible computational power. So this brings us to the theory's ultimate and kind of provocative conclusion. Can a machine that's built on simple bits and bytes ever truly model itself with the same depth and richness as our biological brain? It kind of reframes one of philosophy's most famous statements for our modern age. The philosopher Descartes famously said, "I think, therefore I am." Well, this theory proposes a pretty cool modern update. I object model myself, therefore I am. Our existence, our very sense of self, it might just be the ultimate expression of our brain's incredible software, its unique and powerful ability to build a working model of itself.